Okay, this is day 11 of the second distance learning packet in the math section. So this is going to start off with exponents, and this is something that we've done in previous days, and we've covered this in class, so it should be a review. So I'm not going to do every single problem this time, but I will do a couple examples to get you started. So we're asked to solve these problems, and then it says you can check your answer with a calculator. So it's actually a really good practice to know how to do exponents in calculators. Okay, so let's take a look at number one. So it says the volume of a cube can be found by raising the side length to the third power. What is the volume of the cube below? So remember, a cube has equal sides. So if we were to think of just the volume of any rectangular prism, it would be length times width times height, and all of those are the same number, so the volume is just that one side, or if we write it out, times itself, so all of the sides are the same. Or we could say that this is 14 to the third power. Okay, so using exponents to shorten that up. So in a calculator, or by hand, you would want to use the expanded form, which is the first way that we wrote it. So 14 times 14 times 14. And then you can get your answer that way. So that works pretty well for small exponents. But if it was 14 to the 20th power, then we would definitely need to know how to input an exponent in a calculator. So 14 times 14, 14 times 14 times 14. So 2,744. So the volume is 2,744. And our units, in inches, and then to the third power. Okay, so let's see if we can figure out on this calculator. Again, most of your phones, if you turn it sideways, it'll show you something similar. And if you look in the bottom left of my screen, there's this x and then a small y. So x to the y power. So our question was 14 to the third power. So I'm going to type in 14, then I'm going to hit that button. And now it's waiting for my exponent. So that's going to be 3. I hit equal, and I get the same answer. So that's how we use a calculator to evaluate exponents. And then we can see that there is buttons, special buttons for squared or second power, and then cubed or third power. So not all calculators have that, but a lot of them do, because those are the most common ones that we're going to use. Okay, so let's choose another one. It doesn't really matter. The dot means multiply, so we're just multiplying these numbers. We could kind of simplify like we've done in the past if they had the same base, but they don't, so then we're just evaluating the numbers. I'm going to do number 4. So it says a scientist estimates that after a certain amount of time there would be 2 to the 5th times 2 to the 3rd times 10 to the 5th bacteria in a petri dish. About how many bacteria is this? Okay, so we could take care of each number separately and then multiply them. So 2 to the 5th power, that's the same thing as 2 times 2 times 2 times 2 times 2. So there's 5 of those. And, 2s are not too bad. We can multiply this out in our head. And then we're going to multiply 3 times 3 times 3. Also, not too bad. And then 10 times 10 times 10 times 10 times 10. So let's do this in our head, at least the individual numbers. So 2 times 2, that's 4, and that's 4. So we're just kind of doubling this every time. So 4 times 4 is 16 times 2, so that's 32, times 3 times 3 is 9, times 3 is 27, times, and then with tens, all it is a 1, and then it was to the 5th power, so we have 1, 2, 3, 4, 5 zeros behind it. So 100,000 times a number, we just add those 5 zeros to the back of either of these two numbers, so we can multiply the 27 and the 100,000. But then multiplying that times the 32, that's where we're going to need the calculator. So let's just use that calculator. So 32 times 27, let's do that first. So we could do that actually by hand, 32 times 27. So we get that, so 864. Okay, so 864. And then I want to put those 5 zeros. All right, and then put our comma so we can read this. So we get 86 6,400,000 bacteria. So that's not bad. So we really didn't need a calculator. We could have just multiplied 32 times 27 first, and then added the 5 zeros. Okay, let's continue. All right, so we have some expanded form, and then we need to write it in exponent form, and then we have some problems just like the ones we did, but just without the scenario to go with it. So let's do a couple examples of the first type and then a couple of the second type. So I'm going to do number 3 and also number 4. Okay, so number 3, I'm looking for the similar bases. So I have 4s and then I have 5s. So number 3, we can simplify it as 4. I'm not sure to write this. Not much room here. So 4 to the 1, 2, 3, 4, 5. 4 to the 5th power. So I'm just counting how many 4s there are. Times 5 to the 1, 2, 3, 4, 5, 6, 7, 8th power. So we're just counting up how many of those that we're multiplying together. So there's 5 4s that we're multiplying together. So it's 4 to the 5th. And then there's 8 5s. So it'd be 5 to the 8th. Okay, number 4. So we have the same situation, but these are all mixed up. So let's look at the, it doesn't matter. Let's just do 1/2 first. Okay, since the fraction, I'm going to put it in parentheses. Let me rewrite that. 1/2. Okay, and how many do we have? We have 1, 2, 3, 4. Okay, times the next one would be 2. So there's 1, 2, 3, 4 of those. And then times 3 to the 1, 2, second power. So again, just to make sure, let's just go backwards this time. So we have 1, 2, 3, so it's 3 to the second. And then 1, 2, 3, 4 2, so 2 to the 4th. And then 1, 2, 3, 4, 1/2, so 1/2 to the 4th. Okay, so that's it. All right. The next section, we just need to evaluate. So again, you can do it by hand. You can do it with a calculator. I would try to do it by hand as much as possible, and then a calculator if you need it. All right. So let's do number 7. So it's 4 times 4 times 4. So that's 16 times 4. 16 times 4. 4 times 6 is 24. 4 times 1 is 4 plus 2 is 6. So that'd be 64. Again, check with the calculator. 4 to the 3rd power. So 4. And that special button. Actually, we could have hit that to the 3rd. So let's try it. So we get 64 using the x to the y power button, or 4 cubed, and it's the same, 64. All right, and then number 9. Okay, number 9. I don't know, so it's done. And then 13. 5 to the 3rd power. 5 times 5 times 5. And then times 1 to the 9th. So think about what that is. 1 times 1. So it doesn't matter how many we put. It's still just going to be 1, right? So that's just 1. So all we care about is 5 to the 3rd power. So that's 25 times 5, which is 125. Okay, and again, I'm not going to do every single problem. Okay, you can do the rest. All right, the last part. We have 2 decimal numbers, and we're just multiplying them, and that's it. So let me rewrite it. 25.1 times 34.6. Of course, you can use a calculator, but this is really good practice, and honestly, this is one of the skills that many students struggle at, is multi-digit multiplication. And I think it's a really good practice, especially with decimals. We have that kind of last step to make sure we have our final answer with the correct decimal place. Okay, so this is how I have learned it. Of course, there's different ways, but so take the first digit and multiply it by the top number. So 6 times 1 is 6. 6 times 5 is 30. Put a little 3. 6 times 2 is 12, plus 3 is 15. Put a 0 because I have already done the ones. Now I'm going to go to the 10th place. So 4 times 1 is 4. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. Okay, now into the hundredths place. 3 times 1 is 3. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. So it can get really confusing, especially if we're not careful how we're lining up all of our places. And I would say that's probably the number one place that people make mistakes. You just scrunch up the numbers and you're not really careful about how we're going to add this straight down. Okay, so 6 plus zeros is 6. That's a 4. 5 and 3 is 8. 1 and 5 is 6. 1 and 7 is 8. All right, so this is not our final answer. We have 2 decimal places to move our final answer over. So our final answer is 868.46. All right, so let's just check to make sure using a calculator. So 25.1 and 34.6. 25.1 times 34.6. We get 868.46. Okay, we're good. All right, so we used a strategy to solve it, not the only possible way. And then on the bottom right, it says, how do we know? So what do we do? How do we know that our answer is correct? So we use a calculator. And honestly, in the calculator, and this is how I was taught by my math teachers, is try it as many ways as you possibly can. So in your calculator, type it in like this, hit equals, so what do we get? And then try it again, but do it in reverse order. 34.6 times 25.1. Do that again, 25.1, and let's see what we get. So remember, it's going to be the same answer because multiplication has the commutative property. The reason for this is maybe when we typed it in the first time, we bumped the wrong key and we typed in, let's say, 34.5. Okay, so we get that number. Then we type it again, but since we're typing a different order, our brain is kind of thinking through it again, and then we see if those two numbers match. If they match, then we're good. That's our answer. And if it matches our original one, of course, that's how we know it's the correct answer. So just check it as many times as you can. And that is it.